So we're going to talk about neutralization reactions right now. So up till right now we've been talking about these H plus ions and we've been talking about these OH minus ions. So what happens when these two things come together is that these two ions are going to form a water molecule. Now we need to think of the other part of this. What is this H plus ion with? Let's just say it's with like an A minus ion. And what's this OH minus ion with? It's probably with like a B plus ion. So if the H is going with the OH, this probably means that the A minus is going with that B. And this is really like a special type of those double replacement reactions that we've been talking about earlier in the year. So I guess we're going to get H2O plus AB, but again, we always put the cation or the positive ion first. So I would have Ba there. So the overall format for a neutralization reaction is going to be HA plus BOH makes H2O and Ba. Now notice that I have a single arrow here. We're done talking about equilibrium for a little bit, and we're just back to a reaction. This is not going backwards. These two are gone. We're making products here. And then maybe just to put this into words, acids plus bases make water and a salt. So some type of salt. So let's just practice balancing some of these reactions below. So when HCl reacts with sodium hydroxide, what happens? Well, we're going to get water and salt. So I want you to always just write down that water first, just so we get that down. Now what would the salt be in this case? Well, the Na is going to go with the Cl is going to go with the Na, and we'll get Na written first because it's the positive cation, then Cl second. So we get H2O plus NaCl. Now once we get our products written, let's make sure our charges are balanced. So we have a plus 1, minus 1, that's all good. And then we're going to balance the coefficients, so this one's all good. Okay, next, HNO3, nitric acid, reacting with sodium hydroxide, NaOH. Let's get water down. Now what's my salt in this case? Well, the Na is going to go with the NO3. Na is a plus 1. The NO3 polyatomic ion is a minus 1. Those are balanced out, so this would be my salt here. Just another example of a type of salt. And then we look at our subscripts and everything, and it looks like we're balanced again. This one's all good. What about when we have H2SO4, sulfuric acid, reacting with NaOH, sodium hydroxide? Water and salt again. This time my salt is going to be the Na going with the SO4. Now here's where balancing charges is important. So the Na is a plus 1. The sulfate ion is a minus 2, which means we need 2 of these NAs. Okay, now I need to go back and make sure I've balanced my coefficients. So I have a couple H's over here. I really notice I have 2 NAs here, so I'm going to get a 2 in front of the NaOH. And now I have 4 H's on the reactant side, so I'm going to need a 2 in front of that water. Now this one's going to be really important for when we do our titrations, the experiments coming up, because this means that we have a 1:2 ratio, so we're going to need twice as much sodium hydroxide to neutralize that acid, because this is a diprotic acid, you would say. Okay, now these last two are special examples. These neutralization reactions, it doesn't look like I have a base here, but I have a carbonate. And we remember from the acid-base properties lab that a property of acids is they react with carbonates. And these carbonates actually neutralize the acid. These carbonates are often found in some of those antacid tablets people take. So now here, you're just going to listen and I'm going to teach you. When an acid reacts with something with a carbonate, you're going to get water again. You're going to usually see some sort of fizzing going on, and that is the production of CO2 now. Not H2 gas. And then lastly, you're going to get a salt again. So you're going to get water plus carbon dioxide plus salt. And the salt again would be the combination of this with that. So this salt would be NaCl. And now once we predict the products, water plus carbon dioxide plus salt, now we got to go ahead and balance. Looks like I have one H here and 2 H2O, so I'm going to need a 2 right there. I now have 2 Cl's, so I'm going to need a 2 over here. I have 2 NAs, 1 carbon, and we have 1, 2, 3 oxygens, 1, 2, 3 oxygens. So it looks like we're balanced now. Okay, the last one. HCl plus sodium bicarbonate. I don't care if it's an HCO3 or a CO3. Once you see that CO3 in there, that carbonate, we're going to think water plus CO2 plus salt. What's my salt? The Na plus the Cl. Okay, now we should make sure we're balanced. We have 1 H, 2 H's. Oh, there's another H over here. So we have 2 H's and 2 H's. That's all good. 1 chlorine, 1 chlorine, 1 sodium, 1 sodium, 1 carbon, 1 carbon, 1, 2, 3 oxygens, 1, 2, 3 oxygens. That one is all good. Okay, I hope this was a good start. If you want to try some of the practice twos, feel free, and then email me if you have any questions about them. But if we are good with these 5 here, you are probably in good shape. Okay, I hope this helped. And again, this is how we work through a neutralization reaction.